Hello everyone, in this lesson we will be discussing strategies to prevent drones from colliding with transmission lines. Agricultural drones come with radar as a standard feature. Radar serves as an additional tool to detect obstacles. However, in complex environments or when the obstacles are small, it can be challenging to identify them. In such cases, it is advisable to utilize the remote controller along with the RTK high-precision positioning module to plan the flight route. This planning mode allows for better observation of the operating environment and enhances flight safety. Before commencing any operation, it is advisable to consult with farmers regarding the state of the wires in their fields. In cases where there are thin reticulated cables or diagonal wires, it is essential to physically inspect the wire's location. Agricultural drones typically fly at a height of 2.5 to 3.5 meters. It is important to make sure there are no obstacles within 3 meters above the drone. If the lowest point of a regular power line is more than 6 meters higher than the tallest part of the crops, which is greater than 2 operating heights, it is advisable for the drone to fly underneath it. If the height of the wire is below 6 meters, it is advisable to cross over it. When you come across high voltage lines, it is crucial to be mindful of the safety distance they require. This will help you avoid getting too close to the wires, which can result in magnetic field interference that may cause you to lose control of the drone or even damage the drone due to line discharges. If there are power lines running through the middle of the land plot, it is advisable to divide the parcels into separate lots. And apply a patch spray directly over the power lines. When you come across a diagonal line, you should consider it as an obstacle. It can be challenging to spot the diagonal wire when the agricultural drone is flying directly in front of it, but it is much easier to detect it from the side. Therefore, it is advisable to avoid aligning the diagonal wire with the roots of the drone. In order to prevent accidents involving power lines due to limited visibility during night shifts, it is crucial to plan the land plots during the day. Before carrying out the operation, it is important to carefully choose the takeoff and landing points, as well as the starting and ending points of the route. Additionally, the connection routing and RTH altitude should be selected in a logical manner. It is important to steer clear of any obstacles near the takeoff and landing areas, as well as at the beginning and end of the route. It is advisable to manually perform the takeoff or landing in cases where there are obstacles present at the designated takeoff and landing areas. If there is a tall obstacle above the beginning of the routes, it is important to ensure that the starting height is not greater than the obstacle. If there is a low obstacle at the beginning of the routes, it is important to ensure that the starting height is higher than the obstacle. Additionally, the height during flight should also be higher than any shorter obstacles. Otherwise, there is a risk of landing on top of the obstacle when performing a descent during operations. After the agricultural drone has cleared the obstacle zone, the operational parameters can be re-edited again in order to fine-tune the operating altitude to the desired level. You can also choose to manually take off from the starting point and then perform the operation. Similarly, you can manually call it back from the end of the route. However, when flying manually, it is advisable to maintain a clear line of sight and utilize FPV to aid the flight. If RTK was not utilized to plan the land plot before the operation, offsets should be rectified as well. It is advisable to manually take off to the starting point of the route once the plot has been planned. Then, before carrying out the operation, adjust the starting point of the route above the drone by correcting the offset. This will help prevent any significant positioning errors that may cause the route to deviate towards obstacles. During the operation, it is important to keep the radar turned on at all times to avoid obstacles. If the radar detects an obstacle, you should stop the drone and avoid operating the controller at random. You can determine the location of obstacles by observing the red position on the radar ball. The operation method to release the obstacle avoidance is to move the controller in the opposite direction to the obstacle. For instance, if there is an obstacle ahead of the drone, pull the controller stick on the right side backward to release the obstacle avoidance, for Mode 2. It is important to avoid adjusting the drone's altitude when encountering an unknown obstacle. Voice and drift prompts will be provided to assist with obstacle avoidance and guide on how to disengage from the obstacle. When crossing over power lines using the M+ mode, make sure to push the throttle all the way up to prevent the drone from automatically descending and colliding with the power lines. During the operation process, it is possible to anticipate the route and obstacle location by using the FPV screen. For instance, when flying along the current route, it is important to observe the obstacles and plot boundary obstacles ahead of time in order to plan for obstacle avoidance in advance. It's important to monitor the power level of the drone as well. It is advisable to set the low battery alarm at 30% and the critical low battery alarm at 10%. When the low battery alarm goes off, it is recommended to return promptly to prevent any permanent damage to the battery, especially if the battery level drops below 5%. If you need to share the plot with others after the operating, make sure to mention the obstacles in the plot when sharing it. To effectively utilize the plot map shared by others, it is essential to verify the presence of any potential challenges on the ground and carefully plan based on the current circumstances.